Section 6.4 Area with Applications. In this section, we are going to use definite integrals to find area when a function has negative values, and also to apply what you have learned about definite integral to marginal analysis. The first part is about the area bounded by a curve and the x-axis. As we see the integral as an area, for the function y equals f of x as a continuous function on the interval ab or the closed interval ab, the definite integral from lower limit a to the upper limit b of the function f of x with respect to x represents the net area or the difference between the areas above the x-axis and below the x-axis that are bounded by the curve and the x-axis from x equals a to x equals b. Recall a and b are lower limit and upper limit respectively. We also use the additional properties of the definite integral. As the first one, the integral from point a to point b or the lower limit a to the upper limit b of the integrand f of x with respect to x is the same as negative of the definite integral from b to a of the integrand f of x with respect to x. The other way we can say, if we swap lower limit and the upper limit, the integral sign will be opposite. And the second one, as the integral from a to b of the integrand f of x with respect to x can be written in the sum of the two definite integrals from a to c and from c to b, where the point c is somewhere between the left end a and the right end b, or c is the value between lower limit and the upper limit of the original definite integral. Let's see the first example. We are going to find the total area and the net area of the curve y equals 4 minus x squared on the interval -2, 3. So we're going to plot the graph and see what's going on between -2 and 3. From the graph, we can see that between -2 and +3, there are two portions of the graph. The first part is the graph is above the x-axis. The second part, the graph is below the x-axis. So for this case, I'm going to name it as area 1 and area 2. So we find the area of each one to compute the total area and the net area. For area 1, which is the definite integral from -2 to +2 of the function 4 minus x squared with respect to x. And the area 2 going to be the definite integral, from 2 to 3, because the beginning of the second part is 2, the ending is at 3. Of the expression 4 minus x squared with respect to x, we're going to find the antiderivative of 4 minus x squared to get 4x from using the constant rule, and x to the third over 3 from using the power rule. And then compute the number by using the upper limit first. And replace by the lower limit. We got 8 minus 8 over 3 subtracted by -8 minus, this is -2, sorry, gonna be negative becomes positive 8 over 3. Looks like we have the double value there. So we got 16 minus 8 over 3 minus 8 over 3, which is -16 over 3. So then we can compute this as 16 as a common number, 1 minus 1 over 3, or becomes 16 times 2 over 3, which is 32 over 3 as the exact number for A1. And then we use the same way for the A2. The A2, or the part of the graph, is below the x-axis. So the integral from 2 to 3 of the quantity x minus x squared with respect to x, the antiderivative is 4x minus x to the third over 3. Evaluate from 2 to 3. and replace the upper limit first. We're going to have 4 times 3 minus 3 square, or 3 to the third over 3. And then subtract it by 4 times 2 minus 2 to the third over 3. That will give us 4 times 3, that's 12, minus 27 over 3, which is 9, subtracted by 8 minus 8 over 3. And we're going to get 3 here, minus 8 as a common factor, 1 minus 1 over 3, which is 3 minus 16 over 3, which is negative 7 over 3. We have negative sign. As we see, this part is the part of the graph is below the x-axis. So we can see this as a negative area and this portion as a positive area. So from these two numbers, we can compute the total area as the quantity of the area 1 plus the quantity of the area 2 without the sign. The area 1 is 32 over 3. The area 2 is negative 7 over 3. And that should come out as, this is absolute value, okay? Gonna be 39, which is from 32 plus 7 over 3, or 39 over 3. That comes out to be 13 as the total area. And then for the net area is computed directly from the quantity A1 and A2. Add them together. So A1 plus A2, which is 32 over 3 minus 7 over 3. That comes out to be 25 over 3, or 8 and 1/3. Okay. Now, as we see, the total area is 13. The net area is 25 over 3. But the net area can be computed directly using the definite integral, and the number will come out the same as 25 over 3. I'm going to show you in a little bit. And let's squeeze everything in here. So the net area can be computed as the integral from negative 2 to positive 3 of the expression 4 minus x squared with respect to x. And we have the antiderivative as 4x minus x to the third over 3. And we're going to compute from x equals negative 2 to x equals 3. Replace with the upper limit first. And subtract it by the value from the lower limit, which is 4 times negative 2 minus negative 2 to the power 3 over 3. We got the number here, 12 minus 9, subtracted by negative 8 plus 8 over 3. The first quantity we get 3, and then minus this portion become plus 8 minus 8 over 3. That comes out to be 11 minus 8 over 3. And it turns out to be the same as 25 over 3 as the value that we get from using the A1 plus A2 with the sign.